Okay, I'm at the IXL site, and as you can see, I am on the 8th grade level. If you finish this video and start your packet, and you complete the packet, and then do the coordinate graphs assignment, which I think you'll enjoy, drawing a picture, if you complete all those tasks, you can go back to this site. It's just ixl.com, click grade 8, and you'll see the different activities that I'm choosing within this site. Also a great way for you to practice at home. It's a lot of fun. You can see your levels go up as you understand it. I'm going to start with the assignments that are on your homework. I don't want you to do the packet as you watch it. I want you to watch the video all the way through the first time. But when you start the homework, if you have a question, you can go back, watch the video, scroll to the part where I'm talking about that type of problem, and then solve it along with me for help. We're going to start with coordinate graphs and choose points on coordinate graphs. And you'll see when you get your homework, the first few types of activities look like this. It says which point is at 0, -3. Remember that all coordinates are written as x comma y, x comma y. So when you do 0, -3, that means the x is at 0, so you're not moving over along this x-axis. You're staying at 0, but moving down 3, and the answer is D. You can see I got that correct. This one says graph the point -3, 4. It's the same sort of concept, although you won't have this on your sheet, but it's an x comma y. That means the x is at -3, the y is at 4. So move to -3 along the x-axis. Notice it doesn't have a number here, but it's between -2 and -4. And then move up 4 on the y-axis, and I will put a dot right there. That's what you need to know for coordinate graphs. All right, that shouldn't be too difficult. We practiced that yesterday. If you're going to write it on a coordinate graph, you do the same thing. Just make sure you write it as x comma y. Quadrants and axes. Here's the important part that you need to remember. Now, I'm going to flip to this screen here. And when you have it written on a coordinate plane, it's broken up into 4 sections. Positive x, positive y is quadrant 1. Negative x, positive y is quadrant 2. And just as long as you memorize quadrant 1, 2, then we have 3. It's moving counterclockwise to 4. So in 3, you have a negative x and a negative y. And in 4, you have a positive x, but a negative y, because you go down. So this problem asks you to figure out where 5, 3 is. Well, 5 is positive in the x, so you're moving along the x-axis to your right, and then down 3, and that would put you in quadrant number 4. This is in which point is in quadrant 3. So when we go and look back at the quadrants, you'll see quadrant 3 is going to be a negative x and a negative y, because you're moving further away from 0 on the x-axis and down. So you're looking for a negative x and a negative y, or you can just graph each point and figure it out simply, but it will be -5, -3. Okay, that will take care of the first 4 or 5 problems on your homework. For linear functions, I'm going to move down to linear functions. A linear function, it sounds like a line. A linear function is when you have a function table that has a direct rule that you'll be able to graph it and it'll make a straight line. All the coordinates will make a straight line on it. We call that a linear function versus, you see at the bottom, a nonlinear function. When you graph it, it won't make a nice line, a little more difficult to work with. I'm going to start with, does x, y satisfy the linear equation? You'll have problems like this. Does 3, 1 make the equation y equals 4x? True. 3, 1 and y equals 4x. So you have a point, 3, 1. Does it make the equation y equals 4x? True. Well, remember, all coordinates are written as x, y. So it's saying when x is 3 and y is 1, does this make a true statement? Well, does 1 equal 4 times 3. That is not true. 4 times 3 is 12, and I know that 1 does not equal 12. So the answer to this question would be no. Does 0, 0 when yes? And does 5, comma 0? So when x is 5, is y 0? Well, 0 does not equal 20, so the answer is no. That's how you do those types of problems. What's a little more difficult is when you start graphing a line from graph a line from an equation. This is a little bit tougher skill, and you're going to need some practice doing it. I'm not sure if you'll grasp it immediately. And I can't really work well with here, but y equals x minus 4. Y equals x minus 4, and unfortunately you won't be able to see my graph for this one because it's not showing up. But y equals x minus 4. How do we graph that on a point? Our origin is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on your homework, this graph is drawn for you. Now this is a little bit more difficult, but what you need to do here is find some points. This is a linear equation. So you're going to find some coordinates that make this true. Let's say, for instance, if x is 5, and I'm just going to put in a random x. You could start at 0 and say when x is 0, what is y? But in this case, y is going to be negative, so I'm going to start with 5. When x is 5, y would be, so when x is 5, y would be 1. So that is an ordered pair right there. 5, 1. Let's try another one. Let's try when x is 10. You can pick any couple points. You can do 6. When x is 6, y would be 2. Because 6 minus 4 is 2. So you could graph 6, 2. When y is 10, I'm just going to graph a third point. When x is 10, y would be 6. So 10, 6. Now, you can see it's creating a linear line. What I want you to do is take a straight edge. Now, use your resources. You can use the edge of a paper and line it up to these dots. And connect these dots. And draw arrows. Because in a linear equation, everything along this line will be true. For instance, when x is 8, according to this graph, y should be 4. Well, that makes a true statement. And that's what you do with it says to graph a line from an equation. And I will do one more of those, just so you get a better idea of it. I'm just going to submit it and then show you what it looks like. And you could see, well, when x is 4, y is 0, and you'll get a graph looking like this. So to give you one more, y equals x plus 2. All right, that's a little bit simpler. Y equals x plus 2. So you're going to find some ordered pairs. When x is 0, y would be 2. Why? Because if x is 0, then y equals 2. When x, I'm just going to throw in 5. You can throw in whatever numbers you want for x. When x is 5, y would be 7. So 5 comma 7. On your graph, you would 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. You'd put a dot at 5 comma 7 and 0 comma 2. And then with your straight edge, you're going to connect them. and everything along that line would make a true statement. I'm just going to submit it and show you what the graph looks like. You can see 0, 2, 5, 7, and everything along this line would make a true statement. That's the nice thing about linear equations. That's why you can just graph a line and you have every single answer in the world because a line goes on forever. Graph a line from a function table. This is a little bit different. The only difference between this and the last problem is instead of them giving you the equation, you have to create the equation. In this, find a rule. Well, to go from x to y, it looks like it's just a plus 1. So you would write, and always write it in terms of y equals. You can see 0, 1, 1, 2, and this is something we've done way harder rules all year, so I'm not really concerned with you finding the rule, but you have to write it as y equals x plus 1. Think about it. You want to figure out what y is. Well, y is always going to be 1 bigger than x according to this function table. You can see it. X plus 1 equals y. And it's fine if you write x plus 1 equals y. It's the same deal. And then do the same thing you did for the last problem. Okay, so when x is 8, y would be 9. When x is 5, y would be 6. So you're going to graph it out the same way. The only difference here is now you need to make your own rule. Now I'm just going to press submit for time purposes so you can see what it looks like. 0, 1, and everything along this line would make a true statement. All right, find points on a function graph. Now it's the opposite. It gives you the graph, and you need to figure out the information. When you get a graph like this, make sure you read the title and the labels of the x-axis and the y-axis. In this case, the graph shows how the total number of necklaces Jennifer owns is related to the amount of money she spends on additional necklaces. X-axis, money she spent on the additional necklaces. Y-axis, total number of necklaces. With $2 to spend on new necklaces, how many total necklaces can Jennifer own? Oh, wait a minute. Shows the total number of necklaces Jennifer owns related to the amount of money. Okay, so we have total number of necklaces with $2 to spend on new necklaces. So that would be the additional necklaces side. So you would look at the $2 and find out how many total. So it's asking for the total, which is along the y-axis. So we know the x is 2. Y would be 8. So the answer to this is 8. This graph shows how the total number of textbooks a school can own is related to the textbook budget. So here you have the budget along the x-axis. Here we have total number of textbooks along the y-axis. With $400 in its textbook budget. So you have to look at 400 for the textbook budget because that's the x, and it's asking you about the y. How many total textbooks can the school own? Well, total textbooks is over here. So when x is 400, or the budget is 400, total number of textbooks would be 50. Because remember how you just made your graph, and everything along the line in a linear relationship is a solution. So in this case, it would be 50. All right. The next is linear function word problems. Linear function word problems. This is a little bit tougher. This equation shows how the number of pictures Celeste has taken so far this year is related to the number of days she spends on vacation. P equals D plus 2. Very important to know what these letters represent. D represents the number of days she spends on vacation. And the variable P represents the total number of pictures. So what it's saying is the total number of pictures is related to the days. The pictures will always be 2 more than the days, is what it's saying. So it's asking after 2 days, how many pictures will Celeste have taken? Well, P equals D plus 2. So when P equals D plus 2, that means pictures is equal to the days plus 2. And the question asks about 2 days. So when D, or the number of days, is 2, what does the picture equal? Well, the picture would equal D plus 2. So the pictures would equal 4. Oh, apparently my answer didn't go in here. 4. Correct. Here's a little bit tougher now. This equation shows how the total number of hairbands Ellie owns is related to the amount of money she spends on additional hairbands. So the hairbands equals 7D plus 56. Look what each variable stands for. D represents the amount of money she spends on additional hairbands. H represents the total number of hairbands. With $5 to spend on new hairbands, so D is dollars, or money, how many total hairbands can she own? So when D is 5, it's saying, what is the total? So when D is 5, that means 7 times 5 is 35 plus 56. And 35 plus 56, and you can just add it up, and you will find out that 35 plus 56 is equal to 91. So my answer didn't go in, so 91. Oh, I've reached my daily limit. So I can't practice more problems today, but everything on your sheet you're ready for. You have a nonlinear equation, which is the same thing, just put x and y in and see if it works. And then you have a central angles question. Remember, there are 360 degrees in a circle. So if a value is 25%, then how many degrees is that? What you're finding is 25% of 360. You guys are ready. When you finish, get your sheet from Mrs. Lewis to do your coordinate graphing. After you finish the enrichment packet, you guys can talk to each other for assistance. All right.